Hi, today I wanted to talk about a task that I'm given often, and these types of maps, these data post maps, are typically really time consuming to create. And part of the problem is that often we are given a flat file, something like this is a really simple example, but there can be hundreds of records of data, and many times what we have to do is take this data and then format it into some sort of box like this that you then copy and paste into ArcMAP. It's just not really feasible to do that anymore, and especially when we can collapse it down and just organize it using Python scripting. So that's sort of what I've done right here. You can see that we want data organized by location ID, ascending by sampling depth, and within each sampling depth profile, we want to list the analyte, its result, and if it was a duplicate sample or not. I'll also add in here that one of the things that we can do is format the actual result, underline it or bold it or color it, however we want to do according to exceeding one or more criteria. So again, let's take a look at the table. It's just this flat file like this. It's very important that if you're doing this for multiple tables, that they all have the same header format. Okay, so we're going to take that data and then we're going to import it into a geodatabase. We're just going to import it as an info table. So it's a mirror image, really, of the Excel table. And then once it's in there, we can go ahead and we can post it. We can go ahead and post the data however we want. Now, one of the things to make note of here is that the first thing that I did was to join the data to the table based on the sample ID. And the reason I do that is so that I can have a definition query that just isolates only those samples of interest that I want to sample. Sometimes our data sets, you may have hundreds of points. Well, you don't want to label all those with non-data values. So again, join the info table to your feature class, and maybe you have a field. In this case, I've got something called CMU, and I just calculated that thing equal to this SHMU12 soil. Okay, so we've done that. We've isolated the samples that we want to actually provide labels for, and then what we do is you create a label expression for that. And I've gone ahead and I've done this inside of Python, just because it's this particular scripting tool, IDE or whatever you call this thing. It's got the nice formatting stuff with all the tabs and stuff, so you avoid any errors when you then go and push this into the label expression. So I do all my testing in here. You can see I basically add the info table, I create a SearchCursor query, and then I run it to make sure it works inside of here. So we've got the label expression. You place the thing in here, you verify it, and then you go ahead and you can run it. And so it's a really quick way to get at to accomplish something that otherwise would take just forever, really. So again, this is kind of this little tutorial for this particular project, more of a reminder to myself as to how I did this, but maybe somebody else will find this useful as well. Okay, thanks.